Okay, so binomial theorem. We start with a binomial, x plus y. If I raise it to the power of 0, it's 1. If I raise x plus 1 to the first power, it's x plus y. 1x plus 1y. If I take x plus y and square it, I've got x squared plus 2xy plus y squared. I'm going to do one more. We may have even explored this a little bit, but if I raise x plus y to the third power, it's x cubed plus 3x squared y plus 3xy squared plus y to the third. Okay, I'm going to kind of stop there for a moment. And you see the 1 here, right? This is 1x plus 1y. This is 1x squared plus 2xy plus 1y squared. 1x cubed plus 3x squared y plus 3xy squared plus 1y cubed. Okay, over here, let's make a thing. Have you heard of Pascal's triangle? All right. So you start it with 1 up here, and you go kind of to the left of it and to the right, and you put a 1 and a 1. And then to generate the next line, I come down 1, I go in between these two and add them. 1 plus 1 is 2, and then I bring down a 1. Okay? Then I come over here, just to the left of this 1, start a new row. I add the 1 and 2, that makes 3. 2 and 1. In between, I add down here to get 3, and then I always am going to end with a 1 and begin with a 1. And then 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and that's 1. And then I have a 1 here, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and end with a 1. 1, 6, 15, 20, 15, 6, and 1. 1, 7, 21, 35, 35, 21, 7, and 1. Okay, 1, 8, 28, 56, 70, 56, 28, 8, and 1. I'll stop there at that row. But this row corresponds to a power equal to 0. And I want you to look, when n is 1, that exponent, when that's 1, look at the coefficients here. When n is 2, look at the coefficients. This is a way we could generate all those coefficients. There's another way, which involves combinations. But right now, I think we'll just focus on Pascal's triangle. So I need you to be able to generate Pascal's triangle. All right? Does everybody understand? If you've been following along, try the 9th row. Let's see what you get. Or n equals 9. I'm running out of room on my right, so I'll stop at the 9th row here. Yep, same thing? Okay. So I am going to use Pascal's triangle. I want to show you kind of a technique. write the expansion of some of these following here. Let's do x plus 2 to the 4th power. Write the expansion of x plus 2 to the 4th power. I'm going to use this row. 1, 4, 6, 4, 1. I'm going to leave some space here. 1, 4, 6, 4, 1. These are my coefficients initially. And then I do my powers of x. The first one starts at x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and x to the 0, which is 1, right? You could write x to the 0, but I'm not going to. Well, with the y's, no, not the y's, the 2, I'm going to start over here and go 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, and 2 to the 0, which is 1. So everybody see how I place those? And now, I'll just put my pluses in here, and I'll simplify. This is x to the 4th plus 8x to the 3rd plus 24x squared, 6 times 4 plus 24x, and 2 to the 4th, that's 16. Okay? Now, your alternative is take x plus 2 times x plus 2, get an answer. And then maybe, what's the 4th power? So if you take that answer times itself, you would get this. But this is kind of an efficient means of getting there. Everybody see that? Kind of the pattern? Let's try another one. Let's try one for where a negative is involved. 2x minus y to the 5th power. 5th power. Do you see the 1, 5, 10, 10, 5, 1? So I'm going to go 1, and we'll leave some space. 5, 10, 10, 5, and 1. And I'm going to put 2x to the 5th, 2x to the 4th, 2x to the 3rd, 2x to the 2nd, 2x to the 1st, and 2x to the 0, which is 1. And then I'm going to put negative y to the 5th, negative y to the 4th, negative y to the 3rd, negative y squared, negative y to the 1st, and negative y to the 0, which is 1. Does everybody see how that's filled in? I'll put all my pluses in between. 2 to the 5th power is 32. So 32x to the 5th. You got to do your exponent first. That is 2 to the 4th, which is 16. 16 times 5 is 80, times negative y, though. So it's minus 80 x to the 4th y. Now negative y squared, this one's going to be positive because that's positive. 2 to the 3rd is 8. 8 times 10 is 80. X to the 3rd, y to the 2nd. This one's going to be negative. 2 to the 2nd is 4. 10 times 4 is 40. 40x squared, y to the 3rd. This one's positive because a negative to an even power is positive. 5 times 2 is 10. 10xy to the 4th, and then minus y to the 5th. Any questions on that expansion? Let's do one more. Let's do 5 plus y squared to the 3rd power. Third power, that's 1, 3, 3, 1. 1, 3, 3, 1. Let's do 5 cubed, 5 squared, 5 to the first, and 5 to the 0, which is 1. Let's start here. Do y squared cubed, y squared squared, y squared to the first, and y squared to the 0, which is 1. These are all pluses here. 5 times 5 times 5 is 125. This is 25 times 3, that's 75y squared, plus 15y to the fourth. Second cubed, that's y to the sixth. All right. Any questions? Go ahead, Michael.
Or you can launch the reorder it, so it would be bottom 6 to bottom 4, like if it's only one.
That's fine. Yes. If you, I'm going to go that this is okay, and then it's a little more conventional what you just said. Start with the y to the sixth. Yeah. All right. All right. Now we're going to use this. Let's do an example here. Let's find the fifth term of a plus 2b to the eighth. The fifth term. Okay. This is the eighth power, right? So first term, second term, third term, fourth term, fifth term. Is everybody good that the coefficient is 70? I'm not writing the complete expansion. 1, 2, 3, 4, 5. I'm on the n equals 8 to match that exponent. Now, the first one, I would go a to the fifth. Do you know what I would go with for 2b? Don't look. What would I go for 2b? What have these two always been adding up to on all these? Like 4 and 1, 3 and 2, 2 and 3, 1 and 4, 5, 5 adds up to that, right? Every time that's happening. 2, 1, 1, 2, 3, 3. Those all add up to 3. 3, 1, 2, 2, 1, 3. Okay. If this is 5, this one's 3. It needs to add up. Okay? Adds up to 8. So, let me simplify it a little bit. 70 a to the fifth times 8b to the third is 560 a to the fifth, b to the third. Is everybody good with just using the triangle, finding the fifth term coefficient, first term to the fifth power, second term to the third, so that adds up to 8.
Why isn't it to the fourth? Could it be like 8, 7, 6, 5, 4?
Okay. 8, 8, 7, 6, 5, 4. Okay. You are correct. All right. So they're both 4. Okay. So it's not automatic. That's not the automatic exponent. 8, 7, 6, 5, 4. Thank you, Sophie. You've been keeping me honest all year. Okay. 70 a to the fourth. Does everybody see that? Count when if you got to count the fifth. 8th power, 7th power, 6th power, 5th power, 4th power. 1, 2, 3, 4, 5. But when we count down. Is everybody seeing that? What Sophie said? Move. Oh, the triangle? Yes. 8, 7, so this is a to the 8th, a to the 7th, a to the 6th, a to the 5th, a to the 4th. Okay. That fifth term is not automatically the exponent. So, it's probably one less all the time. Thank you very much. So 78 to the 4th times 16 b to the 4th. 1,020? 1,120? Okay. A to the 4th, b to the 4th. All right. We got that? All right. Ooh. Okay. I don't have a big enough triangle here, and I'm running out of room on the one I got. Find the, for this example, the formula would probably be better, but I'm still going to just stay with Pascal's triangle at this point. Of a to the 4th, b to the 7th, in the expression of 3a minus 2b to the 11th power. Okay, let me just get a piece of paper so that I can keep going the 10th and 11th. You guys have enough room to keep expanding? No? Okay, I'll do it for you. N equals 10. So 1, 10, 45, 120, 210, 252, 210, 120. Do you see the symmetry in these every time? Okay. N equals 11. These middle numbers start getting big quick. 55, 165, 330. What was that? 462. 462, 330, 165, 55, 11, and 1. Okay. A to the 11th, A to the 10th, 9th, 8th, 7th, 6th, 5, 4. 330. Okay. 330 is the coefficient from Pascal's triangle, but it's not the coefficient because we're taking 3a to the 4th and negative 2b to the 7th. Does everybody see how I counted that? 11th, 10th, 9th, 8th, 7th, 6th, 5, 4. 4th power. That's where I got to by counting down. And I'm going to need a calculator on this one. That's 330 times 81 a to the 4th times, is that 128? Negative 128 b to the 7th. I need 330 times 81 times negative 128. It's big. So the coefficient, negative what?
3,421,000.
How much? 440? Negative 3,421,440 is the coefficient of this. Is everybody good with how it was found?
On the A to the 4 and B to the 7. Oh,
Okay? All right.